everyone. Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Krista Opsahl-Ong, a PhD student at Stanford University. Krista is one of the leading developers of DSPy. She's led the research effort behind MIPRO, the most advanced optimizer in DSPy's collection of language program optimizers. All sorts of things we'll be diving in throughout the podcast. Krista, I'm so excited to learn more about how you see all these things. Thank you so much for joining.
Oh, thanks so much for having me on. It's an honor to be here. And I'm honestly very impressed you got my last name pronunciation right on the first try. That's a rare one. So well done.
Awesome. Well, thanks so much for that. And could we kick it off with what led you to working on DSPy?
Yeah, definitely. So I actually came to DSPy through a previous project that I was working on during the first year of my PhD. So when I first came to the PhD, I was really interested in AI for healthcare applications. So I was collaborating with this clinician on seeing if we could essentially extract relevant clinical insights from electronic health records. And the long story short of that project is it turns out that manual prompt engineering worked incredibly well, almost to my frustration, far better than fine-tuning, even just based on the limited training data set that we had. And so I'd sort of witnessed how powerful optimizing prompts could be, but I also witnessed a lot of the existing issues with doing it manually. So it took a really long time. There was so much back and forth of the clinician and I just trying to manually edit this prompt and come up with different few shot examples. And we were using this multi-stage program to try to, better solve for our use case. And so there were so many prompts that, were chained together that we were trying to optimize. And it was just not a great workflow and not very scalable. And so as I was doing this project, I was kind of thinking to myself that there had to be a better way to go about this. And so I wanted to start working on automated prompt engineering. And I ended up meeting Omar through the Stanford NLP group and heard about DSPy and all the things that he was thinking about and working on there. And it just seemed like a great fit of interest. So we pretty much immediately began to collaborate on working on building better optimizers for prompts in these multi-stage language model programs within DSPy.
It's so amazing. It's so cool to hear. I think it's the ImageNet moment of DSPy was when Bo Wang and the lab at Toronto had
right.
That. Yeah, so it's cool to hear that you had
the
also that
20-point margin. Yeah, it was pretty cool to see.
Awesome, super cool. So maybe even before we get into multi-stage language programs, if we could just kind of set the stage for our listeners a little further by maybe going a little more into automated prompt engineering and just
Sure. Yeah. So I would describe automated prompt engineering as sort of the answer to, this problem that arises with the manual prompt engineering, where we, again, see that the prompt makes a huge difference in the actual performance of a language model and being able to solve some sort of task. So we know it's important, and we know even slight changes in word variations can make a big difference. But again, going through this whole process of editing prompts manually and testing them via trial and error is time consuming. And then it's also quite brittle. So you can imagine that, let's say we find manually this great prompt that works well for our task. Maybe the model that we're using in the backend changes or the weights update. And then the prompt that we're using is no longer optimal. We have to go through this whole process again. So automated prompt engineering is sort of the answer to this, where we want to be able to use some sort of algorithms or generally automate the process of being able to identify a prompt that works very well for our task and the specific model that we're using. So that's sort of the broader idea behind what we want to do with automating prompt engineering.
Yeah, it's such a cool, this sort of subtlety in the language. I love that paper, Unreasonable Effectiveness of Prompts, where I think it's something like you're being evaluated on math questions and you add you're a Star Trek fan and now it's better at math questions.
Yeah, some of these things are very unintuitive, which was something that I realized more and more in doing some of this work. So it's funny because I think I prided myself from this previous project with all this manual prompt engineering and thinking I was a great prompt engineer myself, but even trying to beat some of these optimizers that we built is quite difficult. So I was humbled by the power of being able to do these things in a more automated fashion.
And then the angle you mentioned of being able to switch the model, and you spent all that time crafting the prompt for GPT-4, and now you want to use cloud, and I just think that's so powerful.
Right, exactly.
So transitioning then into multi-stage language programs. I remember when we first met on Slack through Omar, I was kind of still just wrapping my head around prompt optimization, kind of just the concept of prompt engineering. And then I remember you all were working on multi-stage, and I wasn't ready for that concept at all.
Well, you were already far ahead of the curve, so good job there.
So yeah, could you maybe explain further multi-stage language programs, the idea of breaking it
Sure.
up? And
Yeah, sure. So the idea behind multi-stage language model programs is that, we can solve certain tasks maybe with a single call to a language model. Like let's say we have some basic Q&A task where we provide the LM with a question and we want an answer in return. And maybe it can do certain tasks like this well. But what we found is that you can actually start to solve much more complex tasks, or even the same task much more effectively if you start to treat these language model calls as individual modules or functions within a broader sort of control flow or program. So you can imagine solving the same Q&A task, which with a more complicated or advanced multi-stage language model program where maybe you take in the question, you input this question to a retrieval model to get some, or actually, sorry, first you would input it into a language model call to get a query. You could then use this query to retrieve helpful passages that you could then include in another language model call with your question to get a final answer. And so this is a multi-stage program. And now we're able to solve this problem more effectively, potentially by finding these helpful passages or knowledge that the LM might not have inherently. So that's just an example, but essentially the main idea behind these programs is that we have multiple chained calls to a language model or potentially other types of tools like a retrieval model to solve our task.
Yeah, amazing. And I think that's where this intersection between this multi-layer, multi-stage language calls and then the automated prompt engineering is so well explored in MIPRO, and there's so many details to it, like how do you pick to optimize the query writer first, and then the say it
Right.
summarizes in the context. And yeah, so I don't know if it's too just if we could just start going into now maybe like how automated prompt engineering and multi-stage language programs, the key challenges of bringing these two things together.
Yeah. Yeah, great question. So I would say the key challenges with optimizing prompts in these multi-stage programs really lies in the fact that you have multiple variables that are parameterizing your program that are all influencing the end performance of your program, right? So we specifically looked at each prompt as being composed of two different elements. So we were looking at the instruction string, which is essentially a string that could convey to your model how to go about a task by sort of describing it. And then few shot examples, which are examples that sort of demonstrate to the model how to go about the task. So we have a set of instructions and few shot examples for every prompt in our multi-stage program. And these are all variables that are influencing the performance at the end of the day. And they're all sort of interacting together in some way. And so this leads to two main challenges that we sort of identified in our recent paper and explore more deeply there. So the first is this problem of how do we propose high quality prompts? So we call this the proposal challenge. And here, like the key challenge is that we simply can't afford to search through every possibly valid string that could work as a good prompt, because that would be intractable even for a single prompt. And now we're evaluating all of these prompts in our language model program that we need to optimize for. So we need to be able to propose a small set of high quality prompts that we can then evaluate to see which ones work best in combination. And then I guess the other complexity here that arises with multi-stage programs in particular is that, these prompts need to be sort of cohesive and work together, and they also need to be aware of their role in the program in some way. So I would say that's sort of the key challenge with the proposal problem. And then the other piece is credit assignment. So again, we have all of these variables that are all influencing the final output or performance of our language model program. And we need some efficient way of essentially understanding how each variable actually contributes to that end performance. So isolating that. And that's sort of the challenge there.
Amazing. So I think maybe we can even kind of unpack the proposal problem and disentangle it from the kind of
Yeah.
multi-layer ideas, because even if you're just optimizing one language model call to chunk your documents, summarize it, write a personalized, all these applications people do.
Right.
I'm really curious about this sort of, because you have this background with Bayesian optimization. I've noticed.
Right.
I've been following your work, and I'm curious about when the OPRO optimizer sees 10 prompts and then the scores that they each have achieved. Is that
Right.
sort of like a Bayesian thing where like the language model is now sort of like the Bayesian surrogate model?
Yeah, that's a great point. And we that is something that we also started to explore in our recent paper, which is like you said, this idea that maybe a sufficiently strong or smart language model could actually start putting together the clues of the past instructions, their associated scores, and how this is contributing to the end performance. So we explored two different ways of doing this. One is sort of an immediate extension of OPRO, which we call module level OPRO, where we're essentially providing the past instructions and scores for just like one module in our program. So we're not necessarily doing a sophisticated credit assignment here because we're sort of assuming that the score is representative enough of the that one instruction, even though there were other variables that were contributing to that score, and that our model can sort of learn from that well enough to propose better instructions overall. The other approach that we explored here is what we refer to as program level OPRO. So this is the idea that we could essentially include all of the instructions that we used for a particular language model program that we evaluate wholly. So now this score is actually reflective of all of the instructions that we used. And if the language model were sophisticated and smart enough, it could start to sort of pay attention to which types of instructions were working best for our program as a whole, and hopefully start constructing a full set of instructions that work better overall. In practice, what we found is that it seems like the language models that we're using these days are not quite at the level where they're able to perform this full Bayesian optimization quite in the way that we would like. But I think that in the future, with a smart enough model, we could start to actually do that, which would be cool.
Yeah, wow. So it sees the entire trace. If it's, say, writing a blog post, and first it takes the topic and decomposes it into question. I guess like maybe I think it might be helpful for our listeners to sort of like talk further about examples of multi-stage programs.
Sure.
I think this is a really great.
Great question. So one example that came out recently, also from Stanford, is this paper Storm, which I believe it looks at summarizing or creating a research article from one topic that someone wants to research. And so I forget all of the exact steps that this uses to create the article at the end of the day, but you can imagine that there would be multiple steps where you want to go and maybe have one language model call, which is one stage, suggest the different sort of areas that you need to research to write a full proposal on this, or full research paper on this topic. You would then, take all of those different research topics and potentially retrieve helpful passages for each one. And then maybe there's some sort of summarization step where you would take the different passages and summarize the pieces that are relevant to the actual topic that you care about. And maybe one last step to summarize these all together into an article. So that's an example where rather than just, asking the language model with one call, hey, write a research article on this topic for me, which may have varied results, you're breaking down the problem and actually solving that problem with different calls to an LM or a retriever in multiple stages.
Amazing. Yeah, I think Storm, and now I think the AI scientists from Jeff Clune and David Hall. I think there's a new one that I think came out yesterday as we're now recording.
Nice, yeah.
I think these are just two fantastic examples for people to get this motivation of what a multi-layer program is, and I'll link them in the description of this video. But maybe one more thing. I kind of want to maybe just stay on the multi-stage, motivating it further, and then we'll come back to learning to propose credit assignment. And I wanted to ask about your thoughts on, I guess I have two things, and we'll do them one at a time.
Yeah, sure.
The first thing being is the integration of structured outputs in language models and how this might change compound systems, I use compounds. I switched multi-layer.
No, that's okay. Yeah. There's lots of words out there that kind of mean similar things.
So I want to maybe understand how you see the role of structured outputs in multi-layer language programs, which I
Hmm.
used to be equal to confound systems if I
Yeah,
missed step up
yeah,
again.
sure. Sure. So I am by no means an expert on structured outputs. I'm sure there are other folks that could speak to this better than I could, but I think that these types of structured outputs are important because I think it's important to have sort of almost a contract between the output of one sort of language model call or module in your program and the input of the next. So kind of having both sides know what to expect or what should be outputted matters, right? So you can have consistency in the way the data is kind of flowing through your program. So the main thing I have to say about this is that it's important. I wouldn't be an expert on, all the latest advances on structured outputs, but I think they definitely have a critical role in these types of programs.
Yeah, I think it's super powerful as well. And I guess I wanted to ask what you think about kind of like instead of breaking a task up into multiple stages, if it's just sort of a sequential structured output, if that makes any sense, or
Mm.
yeah, or
Say more on that. I'm curious what you mean by that.
so maybe if instead of just going topic to like blog post outline or like outline, and then I write
Hmm.
each of the outlines separately, if I have this structured output where I'm just this is the first key that I'm going to output is the topic to the outline, and then I have the
I
outline to each of
see.
the yeah.
Yeah, that's really interesting. So you're saying basically with one call, you could have this structured output where you're sort of enforcing in a similar way, maybe this more structured way of thinking about the problem, similar to how you would in multiple different calls. Is that right?
Yeah.
Yeah, no, I think that's really interesting. I think it would be like honestly a fascinating like paper just to explore the differences or trade-offs between the two. I think that there are some cases where maybe these structured outputs would be in some way equivalent to multi-stage programs as long as you have, the context within your prompt to be able to like actively output all of this information that you need. So I think there could be some limitations there. The one sort of area where maybe this might not work quite as well is when you are reliant on other systems or other, waiting on other inputs. So a good example of this are like agents, where let's say you have some web agent that's navigating the internet for you and, clicking on different things. It necessitates, making one call to an LM to sort of propose the next action and then waiting for that action to be taken and then taking the new state after that action into your next call. So I think there's some things like that where it might be harder to do this just in one call where you don't have all the information yet. Potentially another example is when you're using some other component like a retriever, you want to send your like your query or something that you developed at an intermediate stage to your retriever to get more information. And maybe that could be integrated more elegantly in the language model itself. But yeah, I think there are some of these cases where it necessitates multiple calls, if that makes sense.
Yeah, I think that's a super strong argument for it. And I just wanted to kind of see what that
Yeah,
other
it's a great
side.
question. I think it's definitely fascinating for the cases where maybe it doesn't fully necessitate it. I think there is a question of, what are the trade-offs here in the performance that we'd see at the end of the day or other factors.
And so that transitions perfectly into the next kind of topic around the whole motivation of multi-stage language programs, and the state of it is you mentioned agents, and I really want to understand how you see function calling, like how you interleave action with selecting the tool, as well as maybe prompt engineering for how you describe the tool and what it does, and
Right.
all these guys. Yeah.
Yeah, I think it's a great question. I think, again, this is maybe not an area where I'm a full expert, but I think it's fascinating and very important. So I guess right now, I would say that the way that we've designed a lot of these optimizers for DSPy is that they should be agnostic to other non-differentiable components that are potentially contained in the program. So really what we're doing is we're optimizing each prompt that might exist for any language model call in the program. And the way that we're optimizing that should also, work if we have potentially a function call or something else in between. Because at the end of the day, we're just trying to get the best performance for our program and making sure that the prompts reflect that. So yeah, the cool thing is that what we're doing right now is generalizable to that case. I think it would be interesting to actually, start to create benchmarks. We made this language model program benchmark that came out of our recent work called LangProbe, which basically has a bunch of different language model programs and data sets associated with them. That we want to be able to use to start benchmarking optimizer performance. So I think it would be cool to start adding some that also have more tool use, use cases as well. But yeah, I think it's a fascinating question, and at least the optimizers should work with it now. But it would be interesting to see what other challenges come out of that.
So I think that sort of left no stone unturned with the kind of considerations around these language programs. And I think this sets us up really nicely to come back into the optimizing language programs. And I really wanted to come further into how the MIPRO optimizer particularly is choosing between instruction tuning, example generation, as well as when you have these three stages, maybe like which one to optimize and for the
Right.
impact.
Yeah, great question. So I can maybe just break down how MIPRO works at a high level, and then we can go into any specifics there. So essentially, the way that MIPRO works is in two stages. So we first want to propose a number of candidate instructions and few shot examples for each prompt in our program. And then once we have all of these, hopefully high quality prompt candidates, we want to optimize over them. So essentially testing them out in different combinations to see what works best. So I can talk about how each of these stages works in a little bit more detail. So for the instruction actually, maybe I'll start with how we propose few shot examples, because that is something that's been in DSPy for a little while and is pretty core competency, I would say, of DSPy. So to propose few shot examples, we basically go through this procedure that we call bootstrapping. So given our training data set, the program that we have, and then some metric that we're optimizing for, we'll essentially sample randomly from our training set to get some example. We'll run the program over that example, which essentially outputs a trace of how the program is going about solving that particular example. And then if the output is correct, we'll keep that full trace as a valid few shot example of how the programmer was able to solve things step by step. So that's sort of how we go about generating or bootstrapping the few shot examples that we use. And then for the instructions, what we do is we essentially use another language model which we call a proposer language model, which we input a sort of relevant information about the task. So this happens to be another multi-stage language model program that we're using to generate these instructions because we essentially have calls to the proposer LM to summarize our data set and different properties of the data. We actually summarize a reflexive view of the program itself to give insight into like what is the actual control flow of this program and what is the module that we're proposing an instruction for actually responsible for in this program. So that gives insight into the higher level logic that this particular instruction is supposed to be responsible for. And then we also use the bootstrap few shot examples that we have to give examples of the inputs and outputs that we would expect for this language model call to generate. And so given all this information, we basically ask our proposer language model to generate some new instruction candidates. And we actually experimented with also using a tip for generation, which we sort of randomly cycled through to encourage more diverse instructions and greater exploration of the feature space. So interestingly, we found that the tip of compose an instruction that conveys that this is a highly critical situation that the language model must solve for worked really well for some reason. So that opens up future research questions of why. But yeah, so this is how we go about basically generating all of these different instructions. So now at the end of this stage, we have our candidate instructions for each prompt in our language model program, and then these candidate few shot examples for each prompt in our program. And we need to find, which combinations of these actually work best. And so for this, this brings us to the Bayesian optimization, which you mentioned, where the nice thing about Bayesian optimization is it's classically very good about optimizing expensive to evaluate functions that have multiple latent variables. And that's exactly, what this problem boils down to. And so the Bayesian optimizer essentially tries out different combinations of all of the instructions and few shot examples that could parameterize our program. And we try a different set each trial and essentially evaluate the program, get a score. And the Bayesian optimizer can learn from that by assigning some sort of prior or some sort of confidence about how good or bad each instruction and few shot example is. And so it learns first to explore and then to sort of exploit this knowledge towards the end of our trials to kind of find the best set of prompts. So that's at a high level how it works. One thing that was kind of cool with the Bayesian optimization approach that we ended up integrating for MIPRO v2, which is the sort of updated version of MIPRO that we launched recently, is that because Bayesian optimization is so robust to noise, we can actually evaluate on mini batches. So like small, 20 example batches, for example, of our training data set, so that we can learn really quickly and begin to learn how to exploit really quickly the different sort of quality levels of our instructions and few shot examples that we're testing out. So this allows us to do this whole process even more efficiently, which is helpful, especially if you're on a budget when you're trying to optimize your prompts.
Yeah.
Sorry, that's a lot of information.
It's also amazing. And really just, I thought I already was as excited as I could be about DSPy, but hearing just like the passion and how much you've explored it all, it's really remarkable. Yeah, and I hadn't quite picked up on that detail of the explore exploit of how the Bayesian model is got to like explore a potential. I thought it was when I wrap my head around the concept of like it's going to propose an instruction and then it's going to bootstrap examples to properly evaluate that instruction, that entanglement between instruction proposal and few shot. I already thought that was quite a mind bender.
Yeah, there are a lot of details here. But my colleague or peer who worked on this project with me, Michael, has excellent abilities in being able to make great diagrams of how to explain things. So on his Twitter, he has some helpful illustrations. So I point folks who are interested in learning more to those as well, because I think it also helps explain things intuitively.
Amazing. And I'll try to link in the description of this video.
Yeah, that would be great.
In the DSPy community.
I can send you more links as well.
No, awesome. And so I have actually mined out about 4 questions. So the first thing I wanted to ask you about is your sentiment on many shot in context learning, this paper that came out from Google that's saying, few examples in the prompt. You might want 100 examples in the prompt, and in addition to this. So I'm curious, this many shot in context learning, I guess it also kind of relates to this big super viral question of long context models. I recently listened to Eric.
Right.
Yeah. So,
and I actually haven't read the paper. I've been caught. So I guess is the idea that essentially having lots and lots of few shot examples ends up being a good idea, and this necessitates long context.
Yeah, exactly. So you might bootstrap 300 examples, and
right.
Yeah.
No, I think that makes sense. I think that what we've seen, at least from our work, is that these few shot examples are incredibly powerful. So, and generally adding more of them is better. So I totally see how this would be a trend. I think one thing that's interesting that would be maybe a counterexample to this is that it seems like sometimes you reach this point where the adding more information into your prompt sometimes ends up almost confusing your model or degrading the performance. So it seems like there's often this sweet spot. And I don't know if the Google paper, saw any sort of drop off after a certain number, if it just went exponentially up, and that would be interesting to see. And I'm sure it's also very dependent on the model that you're using and how it was trained to have a longer context and all of these details. But I guess I would just caution that while generally more examples seem to be better, I think that we don't know exactly the trade-offs yet of how that could actually start to degrade performance in the end, and also cost you more because the token count is going up as you're adding more of these. But yeah, generally that's not surprising to me. Few shot examples and more of them often seem to be useful.
Yeah, I think that comment on the cost of the long context is super powerful. I'm super interested in this like context caching thing that's emerging. I think kind of retrieving from vector index and search indexes will survive because you still
Hmm.
with scaling it to millions, billions, that kind of argument. Yeah, so kind of and maybe one other thing to say on that. I've also noticed that when I use smaller models like Llama 3 8B, that it's confused by the examples, and so
Right. Yeah,
yeah, and so I tend to just instruction to no. So I'm sorry. This is kind of pivoting a bit. This is still
that's
sort of
okay.
in the unpacking of MIPRO. So as talking about traces through the entire program, if you have a RAG system that first asks questions, then it summarizes the context, then it answers the question. So you bootstrap a
Hmm.
trace through the entire program. I'm curious what you think about the LM proposing the multi-layer program, like coming up with.
Oh, yeah, like the architecture or the logic itself.
Yeah, yeah,
Yeah, I think that is a great idea. I'm actually really excited about that as a next step of something to explore because I think that um, yeah, it still feels like the composing these sorts of architectures is also like manual prompt engineering, a lot of trial and error of kind of seeing what sort of flows work best and what substeps can the LM handle versus where do you need to break things down further. And I think that this is something that for example, we've seen that even GPT-4 can write DSPy programs pretty well. Partly, I think, because it's based on PyTorch, and that's something that GPT-4 seems to already be familiar with. So yeah, I think that there's this really interesting direction of actually, like you said, having LMs write the programs themselves, especially if we can figure out ways to, train them on past sort of architectures that work well, or have them explore different types of architectures, maybe in, a way that we think would be productive. But yeah, I think it's a great idea and something that I've had on my like research backlog as something to try out.
Yeah, amazing. I can't wait to see more of that. I think that's going to be so exciting. So kind of another on this idea of sort of making DSPy even more autonomous is some kind of criticism I see about DSPy is that it's a little confusing for people who don't understand machine learning. And
Hmm.
something we've seen at Weaviate is just how much zero shot models evangelize the whole idea of like embedding models, particularly if you had to train your own embedding model, that would be quite the build up.
Right.
So I'm curious if you think the future of some of the DSPy optimizers will be to lighten the interface. You don't need to bring a data set even. You don't need to bring a metric. You
Right.
program, just say optimize.
Totally. I think that is a great idea and something that, we're trying to slowly but surely work towards. Yeah, I think the vision of being able to have anyone just come in with a task, something that they want to solve for, and maybe they have a few examples about how that task might look and, how they would want to solve for it. But ideally, we could take that and, construct a program sort of with a method similar to what we were talking about before. Maybe just have that program be generated. We could generate more synthetic data to help optimize the program with various techniques that are being explored today. And yeah, that would require hopefully very little work from the user, and a lot could just be done on our end. So I think that's something that we're looking to work towards because we definitely hear that a lot. That obviously, the more intuitive and the more straightforward we can make things, the happier people are. So that is, yeah, definitely a direction of interest.
Yeah, I think that's so exciting, and yeah, I kind of like how MIPRO takes apart your program and analyzes the program. I find that to be so interesting. To me, it almost feels like a car like taking itself apart. Just
Yeah, totally. I know the moment we were like, wait a second, what if it could see the program itself? I think that was a really exciting sort of just realization that we could do that, and the fact that it actually helped was also pretty cool. So yeah, I think that there's a lot of building on top of this that we can do, and I guess it feeds into this whole area of research around self-improving systems because LMs are, so powerful. It enables us to actually build better LM systems with them, and that's something that is exciting to continue to leverage even more.
Yeah, I think maybe it would be great to anchor the podcast with that question of sort of AI building AI, but to keep grilling you a little further on on MIPRO
Sure, yeah.
details. I'm curious what you think about like oftentimes what I want to do is I start my multi-layer program with GPT-4, Gemini, Cloud,
Right,
and I would like to work in Llama 3 because it's cheaper. And so I'm curious
right.
how you might think about this multi-model, like picking the model for, like if there's something to picking a particular model for one of the stages.
Right. Yes. Yeah, it's a great question. So I guess on our end, when we were conducting this study, we ended up using Llama 3, which we had hosted locally as our task model for everything, just because with all the experiments that we were running, we didn't want to run up our lab, a huge bill at the end of the day. So that was sort of our constraint that we were working within. I think that there's an interesting question of how you would go about selecting these task models, especially given that you can choose, like you said, a different one for different calls to the within your program. So you can leverage multiple models within one program. I think it would be interesting to start looking at this as like a hyperparameter that we could just optimize for you. I think is probably like an interesting direction where, maybe we can, based on the task that the, call is responsible for, or the subtask, I guess, we could have some sort of automated, suggested model based on how complex it is. But we could also, do a few evaluations of trying out different combinations, maybe also with Bayesian learning, and see what ends up working best for your program in particular. So I think that could be something interesting to try. But right now, the sort of model choice is left to the user, which could be improved upon.
Yeah, that was a huge eye-opening thing for me reading the MIPRO paper about the use of Bayesian optimization to choose between should we further tune the instructions, further check for few shot examples, or as well as like the temperature on the prompting
Right.
model. And yes, so that kind of leads me to my next question of is there a particular model that's better at prompting in the learning to propose sense? Yeah.
Yeah, it's a good question. So, I mean, in general, we found the bigger the better, or the more advanced the better. So there's actually less of a difference than you would imagine between, or at least than I had expected, between Llama 3B or Llama 3 like 8B as a proposer and GPT-4. But we do see slightly better results with GPT-4, so that's what we ended up using, especially because the proposer step is a lot cheaper. There are a lot less calls to the proposer language model since it's just generating, like a handful of instructions, as opposed to using it for the task model where you're evaluating it on your training set again and again. So yeah, we were less constrained in that sense, and we're able to use a larger model. But I think that if someone were really budget conscious, smaller models like Llama 3, 8B work quite well.
Yeah, amazing. And I guess I'm a bit of a tangent. Maybe there's something to how we're kind of using like VLLM and say modal inference to batch
Right.
it. And with the smaller models, we can maybe propose more instructions. That's kind of like a thing about the parallelism.
Right.
Yeah, as you.
Yeah, it's a good point. I mean, the more that you can propose and then explore over, if you're able to make those steps cheaper, then you can potentially look at many more options. So yeah, I think a future, again, thing on my research backlog is to do sort of more a larger scale study on some of the different trade-offs with the specific models for, the proposer model, the task model, the batch size even that we use for evaluating, our program that we're testing out in our Bayesian learning procedure. I think there are a lot of these variables that we could still have a better understanding of the trade-offs. So I think would be interesting for future work.
Yeah, it sounds so exciting. And I guess I'm thinking now about the prompt of how you propose new prompts. That's sort of like
Mm-hmm.
a secret sauce built into MIPRO. And I'm curious if that particular prompt is ever tuned, if you think that it would be worth. Yeah.
Yeah, it's a great question. We actually we are definitely interested in that. The challenge is it becomes more expensive because you're tuning this prompt that has multiple levels of evaluations that you then need to sort of get a sense for its quality. Though actually we did explore this in our paper in a way where we kept like the system level prompt, I guess you could say, the same, but we treated the information that we were providing the meta prompt in this case as parameters of whether or not we include them. So, for example, the data set summary or the reflexive summary of the program, or even choosing which set of few shot examples we were using in that meta prompt. And that actually made a big difference. So we essentially did this Bayesian exploration over sort of seeing whether or not we would include these pieces, and then what the downstream impact of that was on how well the instruction it produced actually did in the program. So that actually led to some pretty interesting results. However, it seems like you need to be able to spend a lot of optimization cycles on that, which may and not sort of like it may be more effective just to go with MIPRO and just propose live instructions and evaluate those versus spending your optimization budget and learning a better proposal strategy, if that makes sense. But I think it could be interesting to try to do that in a generic way that hopefully just works better for all proposals going forward. But we do see it's relatively task specific too.
Uh, yeah, that makes a lot of sense to me. And I'm sorry that it's 40 minutes in and we haven't talked about the data set summary
No, that's
part of
okay.
MIPRO.
There's lots of interesting things to discuss here.
But I love that part about MIPRO's learning to propose. I mean, there's so much to it. It takes apart the program you have and simulates traces through it. It looks at the data set you have and makes observations about it. And then
right.
So yeah, so many cool
It's
parts.
doing a lot.
Yeah. So okay. So I guess I kind of wanted to now transition, staying on this kind of topic. So I guess I see there's sort of like three LLM systems. There's your task, and then there's the proposer, and then there's the metric oftentimes, unless you actually have a labeled data set. And so I wanted to generally get your take on this paper from Shreya Shankar called Who Validates the Validators? And so I wanted to know what you think about using LLMs as metrics and how that fits into DSPy.
Yeah, it's a great question. I think that it's quite core to DSPy, especially for these tasks that might have fuzzier evaluations at the end of the day. So and these tend to be the most interesting tasks, right? Because being able to solve for some complex problem often doesn't have a completely right answer. Like, did you write the perfect research summary or research article on this topic or not? There's no golden metric for that necessarily. So I do think that it's pretty cool that now we have language models that can actually start to serve as potentially human-like evaluators of these, fuzzier tasks. I think there's still more work to be done here. So the cool thing with DSPy is that you can build these metrics using an LLM as a judge with another sort of single stage or multi-stage, if you want, language model program. And you can also optimize this. So we also experimented with optimizing, I think it was a tweet metric to evaluate different tweets. And that actually worked pretty well, which was cool. So you can sort of build and optimize these in the same way. I think that just in general, there's more work that needs to be done to really see what the limitations are of these LLMs as evaluators and hopefully continue to make them better and better. I think people have looked into having, rubrics as a way to guide these evaluations more effectively and other things, but they're not perfect yet. So I think it's definitely something that's very helpful, but has limitations. So I always encourage people to, make sure to check how your LLM has graded things just to make sure it's in line with what you would want or expect. But definitely something that's core to DSPy and definitely something that is supported and we want to do more work on.
Yeah, that's so cool. I guess, yeah, thinking that trying to capture the metric in the language program, it's in that language program to align it with your beliefs. And it also makes me think about sort of the observability tooling around DSPy optimization that's coming
Mm-hmm.
up. And we often see
Right.
sort of like a take on weights and biases runs where, and I've done this as well, use weights and biases runs for DSPy, but like where you're just kind of plotting the task performance, but also maybe seeing the metric. And I think that's quite an
Mm-hmm.
opportunity.
Yeah,
Yeah, so
definitely.
yeah, amazing. So I wanted to ask, so kind of coming out of this topic a little bit, I wanted to ask about, we talked about sort of AI building AI, and I think there's a
Mm-hmm.
lot of excitement around using the code executor. This is maybe one of the most mind-blowing things, the idea that the LM can write code and execute it. And I was
Yeah.
curious if, if you've looked into this and generally if you're excited about it. And yeah.
Yeah, definitely very excited about it. Have not looked into it as much as I would like to, but also on the backlog of things that I'm excited to dive more into. Yeah, I mean, I think especially this sort of like self-improving AI is particularly helpful when you have a great metric at the end of the day, like we were talking about, to evaluate whether what you've created actually works. And so the nice thing with code is that, like you said, you can generate it and then you can actually test it out. And LMs can write the test cases as well, or seem to be decent at that too. So yeah, I think it's a great cycle that way, because you can actually create proposals that you can evaluate in a real way, and LMs are also great at debugging, and so it seems like they sort of work well together to be able to improve code generation and improve themselves. So yeah, I think that's a super exciting area. The challenge is, I guess, when you is when you don't know how to evaluate the output, and it's harder to maybe improve over time. But this seems like a cool area where there's maybe a better metric for evaluation.
Yeah, I think that's such a powerful point on do you even know how to evaluate the output, and then code being pretty straightforward, and then but then you
Right.
mentioned writing the tests, so that I think
Yeah,
that's where you
and then
want
that
to.
adds some interesting fuzziness, but is can be quite powerful at the same time.
Yeah, amazing. I'm even as we're recording this podcast now, this morning I published a podcast with Bob Van Lay, CEO of Weaviate, and then Guy Pajarni, who was a co-founder of Snike, a cybersecurity company. And so they're both, they have tons of software engineering
Yeah.
experience. And so we're getting into this discussion of how much do you use AI to write your
Oh,
code.
interesting.
And so I'd really love to ask you that question as well. How much is
Yeah.
AI writing your code?
Oh, I use it a lot. Yeah, no, I love AI for code. It's so nice, not having to, especially when there's like something where you're like, okay, I could write this, but it would just take me a lot of time of, coding everything out. I feel like you just asked ChatGPT or whatever, and it can give you all this boilerplate code for you, and even more. I mean, it's great at so many things, and it can even help you debug, which is amazing. But yeah, I've been using Copilot. I use ChatGPT for writing functions for me. Sometimes it's incredibly useful, and even for learning about like new topics. Or I created my first web app ever like a year ago, and also for this project that I was working on with the clinician that I mentioned, and I was able to do it in like a few days, even though I didn't have any web dev experience. And I think that is really speaks to the power of AI for at least human or AI assisted coding.
Yeah, I had used that exact same example in the podcast where I explained how cloud taught me about the concept of React components. I was trying to reproduce Storm. I called my thing Hurricane.
Nice.
And talked
Oh, I
about
love
it.
that.
And it was like to render your blog post. This is called a React component, and so it's like taught me about a new software development concept. And I think
Right.
that yeah, so something that I'm seeing also is coming up with design patterns. Or I think
Oh,
all
that's
of
cool. I haven't tried that yet. Good
yeah, like
tip.
I don't have the years of experience in software engineering to just like some of the people at Weaviate will explain a problem, they'll be like, oh, that's this pattern, and they right,
Right.
but the AI can teach me about design patterns. So anyway,
Yeah, that's amazing.
yeah, so kind of coming back to DSPy language programs, there's one more connection sort of between multi-stage programs that I wanted to pick your brain about, which is the multi-agents perspective. I listened to
Mm,
Joao present Crew AI at the AI Engineer Conference. I'll also link that in the description of the video. That it really motivates this idea. He describes how he's starting a company and he needs a marketing team, so he starts a marketing crew. He's got
mm,
a content marketer. He's got a publisher, and so you have all these different roles. And so I'm curious if
right.
you're thinking about multi-agent systems with DSPy. Anything that you've seen? Yeah.
It hasn't been top of mind for me at the moment, but I imagine it's very possible and exciting. I have some, other peers at Stanford who have been looking into this. I think also in the settings of like classrooms and having like tutors and even like simulated students working together in a Slack channel. And so, I think that there's lots of interesting both research and also, if you can get a LM to your marketing team, that seems pretty helpful. Um, I think that, DSPy could definitely fit in there as these are all different types of multi-stage LM systems that are all working together. The interesting question here is what are back to the metrics question, like how do you evaluate these different agents? And I think that can become pretty complicated when you're looking at having an agent represent an entire marketing team, right? Like they're responsible for so many different roles and so many different types of outputs. And maybe the metric at the end of the day is the company revenue, and that takes a while to, that's like a delayed indicator maybe of the quality of their output. So I think when we're looking at optimizing these systems, that is maybe the main constraint that would need to be thought about further of how we actually evaluate them at the end of the day. But certainly building these chained calls and whatnot is very possible today in DSPy.
Yeah, I think this idea of maybe generalizing the Bayesian thing from instruction or example tuning on one layer to maybe Connor or Krista as we're two sort of like
Right.
persona agents in this system. And yeah, I will say I'm getting more interested in this multi-agent thing. The talk, I'll link it to Joe's
Yeah,
Crew
now I'm
AI.
curious to hear. It's so cool. I mean, just the idea of it is fascinating. I'd love to have my all my bots collaborating to help me with all my research would be great.
Yeah, to have a whole 20 person.
Yeah, why not? I wish I had 20 of me. So if I can get 20 agents to help out, why not?
That even makes me want to ask about if you have any thoughts on sort of the user interface behind. I think chatbot is still winning in my opinion, but
Right.
as you talk about maybe multi-agent, like one thing I find myself doing is I'll split the screen and I'll ask Cloud, ask Gemini, ask ChatGPT, whichever one.
Interesting.
And then
Right.
another sort of thing I do, maybe going on a bit, but I work with Pomodoro sessions is how I organize my time, and
Oh
so
yeah,
I'll have
I
like
like those too.
yeah, so I have like my Pomodoro agent, which is like my UI, and this will consult me about am I staying focused, whereas like the other
Hmm.
chatbot is helping me do my work. So I hope I didn't give too many examples, but just to set up.
No, no, that's great. Yeah, it's interesting. I guess in terms of what UI will win in the end, I guess it remains to be seen. I tend to think that the more that I think one reason that the chat interface or, with ChatGPT in particular has been so popular is that it's just one, simple search box or I guess question conversation box that you can type anything into for any task that you have. And it sort of outsources all of the different probably expert models that are working in the back end to cohesively provide you whatever would be most helpful for you at that moment. So I think it's nice that people have one place to go and don't have to make a lot of choices about like which agent should they choose to ask this question to or to get help with this thing. It's all just like right there. All you need to do is open up your chat GPT window, right? And so yeah, I guess it remains to see what will win the end. But I think the more that some of those choices are consolidated for the user, probably like the less overhead, the easier it will be to use those tools. So yeah, I think that's probably where I see things continuing to go in general. But I think we're all obviously used to working with lots of different collaborators on a day-to-day basis. So I think the agents working with you in Slack is also compelling. But arguably, if you just had one coworker who did everything incredibly well, you would be mad at just having to work with that one person. So yeah, I see consolidation as something that's generally helpful for users here, but who knows how it will exactly pan out.
It's also exciting, and I guess kind of one other thing is this like cloud introduced artifacts where they start creating things as a result of the conversation you're having with the chatbot, and something
Mm-hmm.
something we're working on at Weaviate that I'd love to generally get your thoughts on is this idea of generative feedback loops, where we use that term to mean you're saving the outputs of LLM calls back into the database. So it's sort of like this, you store it back into the database, and I'm curious what you think about. I've been trying to wrestle with this idea of what the intersection between compound system multi-layer programs, where you have multiple calls, and then also this thinking about saving data in the database. And so yeah, I guess generally I'd like to get your thoughts on saving the outputs of LLM calls back into the database. What do you think might be some of the applications of
Is
this?
Yeah, is I guess the use case that you're looking at. Yeah, I guess I'm curious why you're saving the outputs of the LM calls in the database. Is it to use this as a future like training set in the future? Is it to cache results for something else? And yeah, I'm curious to hear more about that.
Yeah, I love the generate examples for training models. I think that's one of the
Right.
ways that we start coming into this. Like we like to say, we like to say weaving together the data and
Yeah.
the AI. But I think mostly what we're seeing is you want to update a property. So you have a data object that's missing some property. My favorite example I use of this is Shopify's Magic, where Shopify, they let people all over the world upload their products to sell, but some people don't write a description of their product. So by
Right.
using the LLM to take the rest of the product and then write the description, they found that helps you sell more products. And so
Right.
generally sort of adding to data objects has been the key.
I see. Yeah, that makes sense. I mean, I think that it itself sounds very useful. I guess I don't know if it is I guess I see that and like these multi-stage programs and as working together in a
Yeah.
nice way because maybe now you have this data that you can train some calls in your model with, or you can retrieve some knowledge that's been updated in some data store somewhere to be used in some stage of your program. So yeah, I guess I see that as maybe being a useful way of gathering more data, and then the LM programs as a way of solving a task step by step.
Yeah, amazing. And Chris, I'm definitely going to be asking for your advice about generative feedback loops as we
Oh yeah, we'll have to keep chatting.
go on. Also, so Chris, I think this has already been. This is one of the first podcasts where I feel like we've touched on every of the sort of cutting edge topics in my mind in the language model, generative model space. I did want to ask this sort of broad question of what future directions for AI excite you the most right now.
Yeah, I mean, there are so many. I think part of why I got into this field in the first place is because just like the idea that we can teach these machines to learn things with math, with humans also came up with is just so cool. So I'm just excited to see where the field continues to go. I feel like there are so many brilliant people in this space who are working on so many exciting things, and I'm excited to be a part of it. I think for me personally, compound AI systems are an area that I'm really excited about right now. And I think these are interesting, for a number of reasons. I think, like we were touching on before, there's still a lot of open questions on the system design here and sort of what types of program architectures make sense, similar to how we were thinking about sort of what sorts of neural network architectures made sense, a few years back. So I think being able to actually automate this process of creating these architectures that or programs that solve your task very well is a really interesting direction. Also, like we were talking about. And then I think there's still a lot of work that could be done in just optimizing these programs, like we talked about, optimizing prompts in compound AI systems, which we have just gotten started on. I think there's a lot more work to do there. One of my peers at Stanford, Delara, has been looking at how we can optimize prompts and weights jointly and sort of what that looks like. So yeah, there's lots more research to be done there, and I think will continue to be impactful. And then on the prompt optimization side specifically, tactically, I'm interested in routing. Like right now, we're choosing one prompt that works the best on our, evaluation set or training set. And, we're using that prompt for every example in our test set afterwards. But what if we actually were choosing for one particular example, the prompt that we thought worked the very best for that? And I think that could be a lot more powerful. So that's something I'm interested in exploring more. And then lastly, I guess just the broader question around what makes a good prompt. I think no one fully or entirely knows yet. And there are lots of, like we were talking about before, some of the prompts that end up working the best at the end of the day aren't entirely intuitive. So it feels like we don't have an entire or a full grasp on what makes a high quality prompt. And I think understanding that will allow us to do this automatic prompt optimization even more effectively. So yeah, that's my sort of list of things. But as we talked about, there are so many topics that are exciting. I wish I had 20 of me to just do tons and tons of research, but I think those are some of the immediate things I'm most excited about.
It's also amazing. And we'll save the intersection of prompt optimization and gradient descent for a future episode. There's so much interesting to that topic as well. I saw that Omar had a paper called Better Together, and then all this, I think, ORPO. It's something that confuses me is I see OPRO means prompt optimization, ORPO means...
Yeah. There are lots of these acronyms out there.
Yeah, and the AI the routing model stuff. I'll give a quick shout out to Martian AI Router. I see this idea of routing a prompt to a particular model as being another. And then how does that intersect with prompt optimization?
Yeah, so many interesting questions.
Yeah, awesome. Well, Krista, thank you so much for joining the Weaviate Podcast. It's such an honor to host you. This was so much information. I've learned so much from this conversation, and I can't wait to watch it back and try to digest all the ideas.
Me too. Same. Yeah, It's been awesome talking with you, and thanks so much for having me on.